which is basically electrochemistry. And in this electrochemistry, we are going to have the first electrolytic conductance. I'm going to cover the first part, that is electrolytic conductance. So in this part, basically you have already studied it in some of the topics you have studied from current electricity. And you can see the first term that I'm going to introduce is resistance. Resistance, we denote it with R, and you know that it's property of any conductor which resists the flow of charge, and its unit is ohm. And we represent or symbolize it with this. This is your ohm. After resistance, we have conductance. Conductance, we denote this conductance with G, and it is basically reciprocal of resistance. So G will be equal to 1 by R, we can write. And hence the unit, if you are going for unit, you can see it will be 1 upon ohm. That means you can write either per ohm, or you can either write maho. This is your maho. It is just opposite of ohm, that is known as maho, and sometimes it is also per ohm is also known as Siemens. This is also unit. So these are all units of conductance. After conductance, we have either a specific resistance or we call it resistivity. Resistivity. Resistivity, we denote it with rho. Rho, you already know that resistance is directly proportional to length and resistance is inversely proportional to area. And we got a formula in current electricity, rho L by A. And in this way, you can see, you can easily calculate the value of rho. Rho will be equal to R into A upon L. This is your formula of rho. And if you are going for the unit, you can see, if you are going for the unit, you can see resistance is ohm, and here it is area, which means meter square or centimeter square, according to the requirement you can take. And this is your meter. So unit will be either ohm meter or ohm centimeter. And this is also the property of any conductor. After resistivity, and its resistivity has another name, that is a specific resistance. In the same way, we have conductivity or conductance, a specific conductance. Conductivity, we denote it with kappa, and kappa is basically conductivity is inverse of resistivity, that is 1 by rho. So you can also write the formula of kappa in terms of rho. As you can see, this is the first formula, and this kappa can be written as, at the place of rho, I can write this R into A upon L, and then you can write L by A into, I just rearranged it, nothing else. So kappa has a new formula, that is L by A into 1 by R. L by A into 1 by R. So this is the new formula of conductivity. So please do write up to this and then let me know. Everyone done with this? Alan, Heba,
1 minute, sir.
Farhat, Mamuna. Okay, Saifullah Hanifa Aksa. Saif, are you done with this?
Yes, sir.
Okay. Now there is another term which is very important, and that is your cell constant. The fifth term, that is your cell constant. And you know, cell constant is basically denoted by cell constant, and it is denoted by G star. And this G star, basically this G star cell constant is length, uh, what we call length of the conductor per unit area of cross section of conductor. That is called G star, basically cell constant. So if you are going to divide the length of the conductor with the area of cross section of the conductor, you will get cell constant. And here you can see this G star will have unit. You can see either you are going to take the length in meter or area in meter square, you will get per meter, or if you want to take it in centimeter, it will be per centimeter. Now I'm gonna modify this formula. As you can see, there is kappa, and here it is L by A. L by A is what? Basically, this is cell constant G star. And you also know that this is your 1 by R, which is reciprocal of resistance. And what is reciprocal of resistance? Is your conductance, which is denoted by G. So this kappa has another formula, which is G star upon G and G star into G. So you can either write this conductance will be equal to kappa upon cell constant. Please do write it. Are you done with this, Saf?
Yes, sir.
Okay. Now there is two more term that is very important in this chapter, and that is your molar conductivity. Molar conductivity, that is denoted by lambda m, and in some books it is denoted by mu m. And there is another which is equivalent conductivity. Equivalent conductivity. So this formula can be, this is your molar conductivity, that means it deals with molarity. So the formula is quite similar, kappa into 1000 upon, since it is molar conductivity, so there will be m. And if you are going for equivalent conductivity, it deals with normality. In equivalent conductivity, we deals with normality. So the numerator will be same, kappa into 1000, and here it will be normality. So these are some formula on which direct questions has been asked in your NEET. I'm gonna share some question. Please do let me know when you are done with this. Environment setup. Please do solve this question. It is based upon the above formulas. And let me know if you are not able to do it. Will you be able to solve it? Any answer? That is B. Very good, Hiba. Saf, any answer? Alun, Farhad, Mamuna. Obviously, I'm going to explain. As you can see, the normality is given solution at 23 degrees centigrade and a specific conductance, that means the kappa. This is your kappa, which is given as 0.012 ohm per centimeter. This is your specific conductance, that means kappa conductivity, and resistance of cell containing the solution at same temperature was found to be, that means the resistance is given as 55 ohm. Just wait a minute. Are you able to see the screen, sir?
Yes, sir.
Okay, so what I was saying is that this resistance is given as 55 ohm. Now we need to calculate, you can see the cell constant. The cell constant has the first formula, which is very easy. G star is equal to L by A. But we have another formula of this cell constant. K is equal to G star cell constant into G, which is conductance. But conductance is not given directly, so we can directly write at the place of conductance, it is reciprocal of resistance, so we can replace this G with 1 by R, and then we can easily calculate G star cell constant, that is kappa into R. And you can see then G star will be equal to kappa is your 0.012 per ohm per centimeter into R is 50. So if you are going to multiply it, you will be getting 0.66 per centimeter. So the answer will be B. It's easy, right, Alan? Seth, let me know when to change the slide.
Done, sir.
Okay, very good. Very good. Just wait a minute, Seth. I'm gonna give you another question. Everyone. Please do this question. Next question. If 0.01 m solution of an electrolyte has a resistance of 40 ohms, we need to calculate molar conductance or molar conductivity, both are same term. Hiba, any answer? Alan, Saif, Hanifa, Mamuna, Farhad, Aksa.
1 minute, sir.
Okay. Oh, very good, Saif. The answer is correct. Is there any answer from any other students? So see, molarity is given. So I'm going to write it here, 0.01 m. That is your molarity given of an electrolyte has a resistance. Resistance is also given as 40 ohms. In a cell having cell constant, that is G star, is also given, that is 0.4 per centimeter. Then its molar conductance in per ohm centimeter square per mole. That means we need to calculate the molar conductivity or molar conductance, which has a formula kappa into 1000 upon m. Now, if you look at the given quantity, you can see molarity is given, and this is already we know, but kappa is not given. We can easily calculate the kappa. Kappa is equal to, as I told you, G star into G, right? G is conductance, but conductance is not given. Instead, we have this resistance, so we can also write this G star into 1 by R. And at the place of G star, since it is given 0.4, you can write, and 1 by R, that means 1 upon 40. And hence you can write, you are going to remove this term, and this will be 10, and this will be cancelled by 10. So it will be 1 by 100. That means 10 raised to the power minus 2. This is the value of kappa, and I'm going to put it here 10 raised to the power minus 2, and I'm going to write this 1000 as 10 raised to the power 3 upon molarity is given as you can see. What is the value of molarity? I'm going to write the value of molarity is given at 0.01. So 0.01 can be written as 1 into 10 raised to the power minus 2, right? So I'm going to write it 10 raised to the power minus 2, and hence we are going to solve it, and you will get it. 3 and minus 2, it will be 10 raised to the power 1, and here it is 10 raised to the power minus 2. If it will go in numerator, it will be in positive, and you will get 10 raised to the power 3. So this is the value of molar conductance. And it's quite easy, right? Is that clear, everyone? Everyone done with this? Now we are moving to the next topic, that is variation of molar conductivity of weak and a strong electrolyte. A strong electrolyte with concentration or dilution. With concentration or dilution. It's very easy. Basically, what I want to say is that there is a container. There is a container. There is a container in which this is your strong electrolyte and this is your weak electrolyte. Now you know that when you are going to dissolve this strong electrolyte in a solvent like water, it will be 100% dissociated. It will be 100% dissociated. And in weak electrolyte, if you are going to mix it with water or solvent, only 5 to 10% ions will be dissociated. Only 5 to 10% ions will be dissociated. Now, what you are going to do, you are going to dilute it till infinite. Okay, that means basically you are going to just dilute it continuously. And in this case also, as you know that when you are going to dilute the particles, the distance between ions will increase. The distance between ions will increase, and hence they will move faster and conduct more and more. So what is my question is that if you are going to dilute both the electrolyte, a strong electrolyte and weak electrolyte, the variation before dilution and after dilution will be more in which case, a strong electrolyte or weak electrolyte? Basically, the question is that both are conducting before dilute and after dilute. But if you are going to dilute it, one of them will conduct more than the previous one, and that is your weak electrolyte. Because as you know that since it is a strong electrolyte, all the ions will be dissociated. 100% ions will be dissociated with 100% ions will be dissociated. Now, if you are going to dilute it, what will happen? Basically, the distance between the particles or the ions will increase, and it will move faster and conduct more and more than the previous one. But in case of weak electrolyte, if you are going to dilute it more and more, then instead of dissociation of 5 to 10%, it may increase up to 20%, because it will weaken the weak electrolytes and it will basically break down. That means basically if you have initially 5 to 10% dissociated ions, you will be getting more than 10% ions. That means new ions will produce, and hence since new ions will produce, it will conduct more than the previous one, its own previous one. So if we are going to plot a graph for this, you can see the graph is in between molar conductivity and C raised to the power half. C is basically your concentration. I'm going to write molar conductivity. You know that Siemens centimeter square per mole, or either you can write per ohm centimeter square per mole. And this C is basically your mole per liter raised to the power half. So here the graph for a strong electrolyte is like this. This is for KCl. And if you are going for weak electrolyte, it is like this. This is your CH3 organic acid, which is weak electrolyte. Now, how you are going to read this graph? You can see if you are going from left to right, that means you are decreasing the concentration. You can see if you are moving from left to right towards origin, the value of concentration decreases. That means if the value of concentration decreases, that means dilution increases. So if you are going to dilute it, indirectly I'm saying, so you can see molar conductivity increases drastically as compared to the strong electrolyte. If you are going to dilute it, it is changing itself. There will be increment of molar conductance in a strong electrolyte as well, but the variation in case of weak electrolyte will be more as compared to a strong electrolyte. Is that clear, everyone? Please do let me know.
Yes, sir.
Okay, let me know. Can I change the slide?
Sir, can you scroll up, please?
Yeah. Is it enough?
Yes, sir.
Are you done with this, Saf?
Yes, sir.
Okay. Now we have another topic, that is Full-Rod's law. Full-Rod's law. Now see what it is. Before that, just wait a minute. There is another equation for this molar conductivity and molar variation of molar conductivity and all, and that is your only for a strong electrolyte. Only for a strong electrolyte. In the previous graph, as you have seen, the graph was like this. The graph was like this for a strong electrolyte. A strong electrolyte, this is your lambda m, and this is your C half. And on this base, this is for only for a strong electrolyte, and the equation is lambda m is equal to lambda naught m minus a into C raised to the power half. And this graph, this equation is known as Debye-Huckel-Onsager equation. Debye-Huckel-Onsager equation. And you can see this lambda m is molar conductivity at any dilution. This lambda naught m is molar conductivity at infinite dilution. Any dilution and infinite dilution, this A is constant and C is your concentration raised to the power half. This is your concentration. And this equation is valid only for a strong electrolyte. So please do write it. When you are done with this, Saf, Alan, Alan, are you done with this? Saf, Hanifa, Mamunna, Farhat, Hiba, Aksa.
Yes, sir. Yes, sir.
Okay, very good. Now see. The next topic we have is Borlaug's law. And this law is for a strong as well as weak electron. This is valid for a strong as well as weak electrolytes. Now, as you can see, it says that lambda equivalent of any electrolyte will be equal to the sum of their cation and anion. Sum of their cation and anion. Lambda equivalent of cation plus lambda equivalent of anion. Basically, what I want to say is that if you want to calculate equivalent, molar equivalent, or equivalent conductivity or equivalent conductance of NaCl, if you want to calculate, this is your equivalent conductivity of NaCl. This can be equal to the equivalent conductivity of, NaCl will be dissociated into two parts, Na plus plus Cl minus. So this will be equal to lambda equivalent of Na plus plus lambda equivalent of Cl minus. This will be the scenario for equivalent conductivity. Is that clear? All of you?
Yes, sir.
If you have another just wait a minute. If you have another lambda naught equivalent of MgCl2, I'm talking about equivalent conductivity right now, not molar conductivity. If there will be M, that means molar conductivity. If it is E or EQ, it means equivalent conductivity. Again, this will be lambda naught equivalent of, magnesium will have will be cation and it will be +2, and this will be equivalent of Cl minus. But when you are going to do the just write it first. You don't need to balance it. If you are going to write the uh, dissociation equation for MgCl2, it will be Mg plus 2 plus 2 Cl minus. There is 2 moles of Cl minus, but in case of equivalent, you are not going to multiply it by 2. But in case of molar conductivity, you have to multiply it by 2. Because in mole concept, we need to balance the equation. In equivalent concept, we don't need to balance the equation. Please do write it up to this and then let me know. Are you done with this? Everyone done with this? Staff? Hanifa? Alan?
Yes.
Okay, I'm gonna change the slide. Now, if you want to write the molar conductivity of any compound, a strong electrolyte or weak electrolyte, you know that if you are going to dissociate it, you will be getting Na plus plus Cl minus. This is the balanced equation. So what you are going to do, you just need to write lambda naught M, and here Na plus, and again there will be lambda naught M, and here Cl minus. You can see this is 1 mole, this is 1 mole. So you just need to multiply it by 1 or not, it will not affect it. But if you are going to write the lambda naught M molar conductivity of MgCl2, this will be equal to lambda naught M Mg plus 2 plus lambda naught M Cl minus. But when you are going to dissociate MgCl2, you know that what you will get? You will get 1 mole of Mg plus 2 and 2 mole of Cl minus. Since molar conductivity is there, and you can see there is only 1 mole, so either you are going to multiply it by 1 or not, it will not affect. But here it is 2 moles, so you are going to put 2 here. In case of molar conductivity, you need to balance the equation, and accordingly you need to multiply in the equation. Are you getting my point?
Yes, sir.
So basically, equivalent conductivity, according to the this called Lorentz law, the equivalent conductivity of any strong or electrolyte, any strong or weak electrolyte, will be equal to the sum of all the ions in that electrolyte. Please do write it, and then I'm going to give you some questions. So I'm going to start it from very basic. Let me know when you are done with this. Are you
Done,
done
sir.
with this? Very good. Now I'm going to give you a very easy question on that topic, the topic that we just covered. So here is the question, you can see. Very good, Saifullah. Any answer from Alan? Why are you not responding at all? Hanifa, Farhat, Hiba, Mamuna, Aksa. So as you can see, we need to calculate the equivalent conductance. And I told you, in equivalent concept, we don't need to balance it. You just need to write Al2SO4 whole thrice, and you can just dissociate it, and you can see there will be 2Al plus 3, and this will be 3SO4 minus 2. But if you are going to write the value of lambda EQ of Al2SO4, Al2SO4 whole thrice, you know what will be the value? Lambda naught equivalent of Al plus 3 plus lambda naught equivalent of SO4 minus 2. You just need to, you don't need to multiply it by 3 and 2 in this aluminum and SO4 minus 2 respectively. But if you will write the value of molar conductivity of this Al2SO4 whole thrice, you know, you are going to write lambda naught M of Al plus 3. And since we are talking about molar conductivity, You need to balance it. Since it is 2 moles, so you are going to put 2 here, and here it will be lambda naught m SO4 minus 2, and here you can see 3 mole it is, so you need to multiply it by 3 in case of molar conductivity. But here in this question, you can see we need to calculate only the equivalent conductances. So the answer is C. Very good, Farhat. So can I change the slide? Please let me know. Okay, moving to the next question, which is this. The molar conductivity of H2SO4 and all are given, H2SO4, K2SO4, CS3, C double OK. You need to calculate the molar conductivity of CS3, C double OH. So please do calculate it, it's quite easy. I'm waiting. Hiba, very good. The answer is correct. Sorry, Hanifa it is, not Hiba. Any answer from you, Saf? Alan? Should I explain? Okay, see. Following limiting molar conductivities are given. Limiting molar conductivities are given. This is for MH2SO4, X, and K2SO4. So I'm going to write this lambda m naught of H2SO4. This is your H2SO4. So we can write since we are talking about lambda naught m, So this is your H plus. So I'm gonna put it 2 because 2 hydrogen is there. And then lambda naught M of SO4 minus 2. SO4 minus 2. Now the next is K2SO4. So you can write lambda naught M K plus, and you know that there will be 2 mole of this, and then lambda naught M of again SO4 minus 2. Now we have lambda naught M of CH3C double OK. Now there will be lambda naught M of CH3C double O negative plus lambda naught M K plus. Now we need to calculate the value of lambda naught M of CH3 C double OH. CH3 C double OH. And for this, you know what we require? We require lambda naught M of CH3 C double O minus plus lambda naught M H plus. So basically we need this and this. So you are going to search it in this very good, sir. In these 3 equations. So CH3 C double O minus is there in which equation? Third equation, and H plus is given in the first equation. So what I'm going to do, I'm going to add 1 plus 2. And as you can see, with 1 plus 2, in 1 plus 2, you are getting this as well as this as extra. And also we don't need 2 moles of this. We don't need 2 moles of this. So what we are going to do, I'm going to divide the first equation as from half. I'm going to divide it by 2. And in the third equation, you can see you need to add the third equation. So I'm gonna write 1 plus 3. And in third equation, if you will look at it carefully, just wait a minute. There is 2 mole, so we don't need 2 mole, so it will be 1 mole H plus will be there, and this will be half SO4 minus 2. Okay, and then you are going to subtract the second equation and divide it by again 2, and you will get your answer. So as you can see, this H2SO4 has X value, X, and X divided by 2, plus the third equation has value Z, and Z is as it is, minus the second equation has value Y, which is divided by 2. So you can see X by 2 minus Y by 2, I can write like this, plus Z. So we can also write in the way X minus Y by 2 plus Z. So the answer can be this. Answer is this. Is that clear, everyone? Anifa, Alan, Anifa, you have done it. Alan, are you there? Farhat, Hiba, Mamuna, Aksa, everyone done with this?
Yes, sir.
Okay. Now I'm going to change the slide. I'm going to give you another question on this. This topic is quite important for your syllabus. Limiting molar conductivity. The next question. Very good. Tap. Alan, there is no answer from you. Are you facing any kind of problem in solving the question? Okay, see, in order to calculate the value of NH4OH, you just need to check it. So if you are going to just open it, it will be lambda m NH4 positive and then lambda m Cl minus plus lambda not is there, lambda naught m Na plus lambda naught m OH minus, and minus is there, lambda naught m Na plus. Since minus is there, so there will be lambda naught m Cl minus. Now you just need to check it carefully. Cl minus positive, Cl minus negative will be cancelled. Na plus positive, Na minus negative will be cancelled. Now positive positive. So when this part and this part will combine, it will form NH4OH. So your answer is D. Very good, Hanifa. So the answer is D. Now go for the question number 6, which is very important. Just wait a minute. Question number 6. Please do it. Oh, very good, Saf. Did you solve it?
Yes, sir.
That's good so far. Very good. Hanifa and Alan, any answer from both of you? Okay, see, it's the same as the previous one. Molar conductivities of this NaCl is given. So it's also the same question from NCRT. This question comes from NCRT. NaCl is given. Since we are talking about molar conductivity, so you need to balance it as well. So Na plus lambda naught m Cl minus. Very good, Alan. Now, if you are going for HCl, so HCl will also be like this: lambda naught mH plus lambda naught m Cl minus, and then comes your lambda naught m CH3COONA. That will be equal to lambda naught m CH3COO negative plus lambda naught m NF plus. Now you need to calculate the value of this CH3COOH, which is quite similar to the previous one. Okay, so for CH3COOH, you just needed lambda naught m CH3COO negative plus lambda naught m H plus. So you just need to see this is there and this is also here. So you just need to, this is your equation number 1, 2, and 3. You just need to add 2 plus 3 as we need H plus and this. And there is extra, that is Cl minus and Na plus. So that will be removed with the help of negative. So you just need to write the value of this, which is 425.9, and then plus third equation, that is 91, and minus the first one. And you will be getting your 390.5 Siemens centimeter square per mole. Isn't it easy? Everyone done with this? The last question on this, then we will move to the last equation. Please do this. Very good. Alan, any answer? You can see Ba plus 2 and Cl minus is given, the value of this, and we need to calculate the equivalent conductance of this. So equivalent conductance of BaCl2 will be equal to equivalent conductance of Ba plus 2 plus. Since we are talking about equivalent conductance, this will be no need to balance with the moles of the dissociated ions, and you just need to write the value 127 plus 76, and that will be equal to 203 Siemens centimeter square per equivalent. Since we are talking about equivalent, so it will be like this. Okay, and since you can see only this value is given per ohm centimeter square, so Siemens centimeter square you can write. So please do write per equivalent. Okay. Let me know when you are done with this. Are you done with this? Saif?
Yes, sir.
The next topic is a relation between delta G and E cell. Relation between delta G and E cell. Now, delta G is equal to minus NF E cell. This is the formula. Now, with the help of this formula, we can easily predict whether a cell is spontaneous or not, or a cell is feasible or not. Wait a minute. So, delta G equals to minus NF E cell. So, whether a cell is feasible or not, we can easily decide it. As you know that delta G is less than 0, then it is spontaneous, and delta G equals to 0, then it is at equilibrium. And if delta G is greater than 0, then it is non-spontaneous. Non-spontaneous. Now, as you can see, delta G here, I'm going to write it again. Delta G is equal to minus NF E cell. So basically, if you look at N is the number of electron lost or gained. Basically, there will be oxidation or redox reaction will be there. Number of electron gained or lost. So it will be always positive. F is Faraday's constant. F is Faraday's constant. Just wait a minute. F is Faraday's constant. Now, Faraday's constant is 96,500 Coulomb. Now see, this is always positive because it is number of electron gained or lost, and this will also be always positive because it is constant which has a value plus 96,500 Coulomb. Now, in order to be feasible, if the cell is feasible, then E cell is greater than 0, because you can see this is positive, this is positive. If this will be positive and there is already negative in the cell, E cell is great. If E cell is positive, because these two are constant, that is positive, then delta G will be lesser than 0, and hence the cell is feasible. And if E cell is negative, you can see these both are positive. If this will be negative, negative is already in the formula, and delta G greater than 0, and it will not be feasible. Not feasible, that means not spontaneous. Are you getting my point? Yes or no?
Yes, sir.
So if any cell is feasible or not, what you need to check is the value of E cell, and you know how to calculate the E cell. E cell is equal to E right minus E left, or E cathode minus E anode, if you remember, right, from electrochemistry class 12. That is how we calculate the value of E naught cell or E cell. So please do write it. No, let me know when you are done with this. Let me know when you are done with this. So I have Sir, are you done with this? E cell, write a formula for E cell, that is E right minus E left for representation. And E cell is equal to E cathode minus E anode. Please do let me know when you are done with this so that I'll change the slide. Hanifa Allen Staff. Okay. Moving to the next topic, that is your Nernst equation, which is very, very important. The important topic first is your Corlo's law. After that, this is most important. I'm not saying it in decreasing order. These topics are very, very important for you. Now, for not Nernst equation, I'm going to start this. If you have E naught cell, if you want to calculate, this will be E naught cathode. Whatever is the value of E naught at cathode, if you are going to subtract it at anode, whatever is the value of this at anode, then you will be getting the value of E naught cell. E naught cell. Now there is another formula, delta G is equal to delta G naught plus RT ln Q, RT ln Q. And from here we can easily get delta G is equal to minus NF E cell. So these are some formulas that you need to take care, which is very, very important. Now from this we can easily, this is your Nernst equation, E cell is equal to E naught cell minus 2.303 RT upon NF log Q, log Q. Log Q, you know that Q is your quotient, reaction quotient, or K is your reaction equilibrium constant. That's just like that we can write this. Now you can also write E cell is equal to E naught cell minus, after writing the value of R, T and F, you will be getting a value 0.059 upon N log Q. Q is basically log, if you want to write product upon reactant, and you know that this Q is a reaction quotient which comes from equilibrium, chemical equilibrium reaction quotient. And you also know that in reaction quotient or equilibrium constant expression, the value of pure liquid and pure solid, we don't consider it. I already told you. So whatever is in aqueous state or gaseous state, you are going to write the value here and here as well. So please do write it. This is your Nernst equation. Please do write it.
So what does delta G represents?
Gives free energy.
Delta G naught?
A standard gives free energy. Whenever in this physical chemistry you are using naught, that stand for a standard, that means a specific temperature and pressure. And here a standard means the temperature is 298 Kelvin, that means 25 degrees centigrade, and the pressure is 1 atm or 1 bar, you can consider 1 atm. Just let me know when you are done with this, sir. Saif, are you done with this? Not responding at all. In this batch, almost no one respond. Now see, this is your question. For the cell reaction, this is the reaction, and its E naught value is given. The standard gives free energy. Delta G naught you need to calculate. So you already know delta G naught is equal to O minus NF E naught cell. E naught cell is already given. F, you know that 96,500 coulomb, and n is basically number of electron gained or lost. So you can calculate it. Basically, if you know the redox reaction from class 11, the oxidation state, you can calculate it easily. Will you be able to calculate it? Yes or no?
Yes, sir.
Okay, please do let me know the answer. I'm waiting. The answer is not B. It's A actually. Let me show you. And number of electron, how many you have taken, Muhammad Saifullah? You can see.
1.
No, it will not be one. Fe plus 3 is going in Fe plus 2. So you can see the change in oxidation number is 1. But if you will look at it, there is 2 Fe plus 3. So for 1 Fe plus 3, there is only one change, right? So for 2Fe plus 3, you have number of electron 2. Yes or no, Sir?
Yes, sir.
So you are going to put 2, 96,500 coulomb, and E naught cell has a value what? 0.24. Then if you are going to solve it, you will be getting 46.32 kilojoule per mole. So the answer will be A. So that's why you need to be careful. Whatever you are thinking, the examiner will set the question according to that. So be careful while you are going to solve it. Okay, for 1Fe plus 3, it's obvious that is the number of electron is transferred 1. But there is 2Fe plus 3. That's why it is 2. Okay, everyone. So in the next class, we are going to cover some questions on this as well as then Faraday's law of electrolysis. Faraday's law of electrolysis. Is that clear, everyone? This will be the next topic in which almost we will cover all the chapter, this chapter in the next class. And also please do revise. This is very easy